I'm going to share my screen again. Okay, so we're going to dive right into our first activity. So one of the things that we suggest in a lot of these lessons is kind of like an experience to grapple with content before the actual hands-on part. So we'll be modeling that right now. And my prompt is, what is the difference between rocks and minerals? And I put an image there as a hint to help you refresh your memory to high school earth science. So if you think you know the answer to this, you can raise your hand virtually or physically. You can also write in the chat, which Fran will be monitoring. So what do you think is the difference between rocks and minerals? Any chat action, Fran, yet?
Our brains are still working.
Okay. So I'll give you. Oh,
Lester says rocks are made up by tiny materials. He says in question.
Ooh, okay. Do you think you know what these tiny materials might be?
Sorry, tiny minerals. Rocks are made up of tiny minerals by tiny minerals. That's Lester's comment, but he puts a question mark.
Okay.
He's letting doubt in.
Okay.
Antonetta shares minerals are naturally occurring.
Okay. Can I just talk as opposed to put it in the chat?
Tell me. Totally, yeah.
Yeah, okay. I hate reading. So I'm going to say that rocks, that minerals are sort of the ingredients inside of rocks. And so rocks can be made up of multiple different types of minerals. So that's it.
That's great. That's great. And I think a lot of you are definitely on the right track, and that's definitely right. So in the picture, the item that says granite is an example of a rock, and the building blocks of granite are mica, feldspar, and quartz. So those minerals make up granite. So those are the building blocks. So great job, everyone that shared their thoughts.
So Jasmine, can I ask you a question?
Yes.
So are there certain proportions of mica, feldspar, and quartz inside of pieces of granite, or is it just haphazard?
It will vary with the piece.
Okay.
But those will be the building blocks. So
okay.
You know, some you'll notice will be more pinkish, which means that it has more of that mineral. Some will be more like a darker color, which would say that that particular piece of granite has more mica in its makeup. So that's going to vary.
Okay, thank you.
You're welcome. All right, so someone had mentioned that a mineral is natural, right? So it's a naturally occurring inorganic element or compound having an orderly internal structure, characteristic chemical composition, crystal form, and physical properties. So basically, all that's trying to say is that a mineral is something natural, and there are certain properties that it has that's unique to it, okay? And as we said before, rocks are an aggregate or are made up of minerals. And here's the breakdown again. You'll notice that the dark pieces here, they don't say mica, it says hornblende. Sometimes that will vary. So some granite will have mica, some will have hornblende. They're very similar, if not the same. And it'll always be that darker color in granite. So I love to use granite as an example, because you can clearly see color differences in there and speak towards those specific minerals that make up that rock, okay? Now, here is a chart that some of you might be familiar with. This is Mohs hardness scale. I want you to take a look at the different columns and just overall at the whole graphic. And if someone would like to raise their hand and say a little bit about what you think this chart is saying. Like, what is the information that it's trying to convey? And this is a strategy that you can use with students, is to have them kind of like analyze data and make sense of it. Okay, so what do you guys think this chart is about? What is it trying to tell us?
It's Tahira from Frederick Douglass Academy. I think it's just it's comparing where the hardness is from the mineral to the object. So when you show like a steel nail, a knife, copper penny, fingernail, masonry, drill bit, it can compare for the children to actually see something that's, you know, real to them and equivalent to the mineral and its hardness.
Excellent, excellent. So you think that the common object is kind of like an example of the strength of that mineral. Okay. All right. I love that. I love that. Does anybody else want to share?
I'd like to share. It's Sue.
Okay. Hey, Sue.
I think that it probably that we can scratch the surface of the rock with those particular items. Like, for example, if the rock is very soft, like if it's a soft rock, we could probably scratch it with our fingernail. But if the rock is really hard, right, then like granite tops, right, that you have on your countertops, if you were able to scratch that with your fingertip, then it wouldn't make for a good countertop surface, right? So that's why the hardness, I think the hardness is probably going to be like a lot harder than a nail, right, to scratch it. So that's what I was thinking, that maybe it has to do with the softness or the hardness of a rock. We always think a rock is something super hard, and it's probably not. You know, there's probably rock surfaces that are very delicate, and that's probably how like erosion occurs and stuff, right? Okay, I'm gonna stop talking.
I love that. I love that. So, you know, something that Tahira said, you know, the strengths of these common objects, you know, are related to the mineral. And with Sue adding that it can actually scratch that item is correct. So for example, something like talc, you can scratch with a fingernail, which would tell geologists that on the Mohs hardness scale, it would be like a 2.5. Whereas something like a diamond can barely be scratched by even a drill bit. So the hardness of a diamond is greater than 8.5. It's actually the hardest mineral out there. So if you have an in-person experience with students at the site, one thing that they can actually try is if you can get some examples of these minerals, probably not a diamond. You don't want to bring diamond samples to kids, but some of the other examples that are on there, there are some kits that they sell with a few minerals and a couple of items like copper penny, steel nail, a piece of glass that's kind of like square, so it's a little bit safer. And they can actually conduct these tests to see what is scratched by the rock. So not only could they analyze this chart, but they can also try it in a hands-on way if you're able to get those kits. And, you know, it would be a nice, like, actual experience for them to do, because geologists do that test all the time.
So Jasmine, can I ask you a question? Going back to the hardness scale for a second, like how do people, you know, obviously for me, if it's not applicable, like if I can't like see it in my own surrounding, then it's more, you know, academic, and it belongs in sort of like a school and not in the real world. How do let's say construction people actually do they use this hardness scale for anything, like for construction material or anything like that?
Absolutely. I think the example you gave was wonderful with the granite countertops. So when engineers or construction workers, for example, they're working with rocks, they may have an advantage if they understand the minerals that make up that rock. And if, for example, some of those minerals are higher up in the hardness scale, that means that that sample of rock might be a great structural thing to use for what they're building. For example, a granite countertop, right? So that's one way that you can relate this particular content to the real world, because it helps geologists and engineers make decisions on stability and strength of the materials they're working with.
And I'll jump in, this is Fran, that in our background materials for reading in the lesson, one of the kind of classic New York stories is that there are skyscrapers in Midtown, but not in other parts of the city. And why is that? And it has to do with the ground, what rock is there and the schists that can handle that weight. So that's another way to make it real of where buildings can be built and what is under the ground to support this kind of weight. That was a great resource, definitely for kids, you know, because they'll, if you show them like an aerial satellite map, you'll be like, they'll see, oh, wow, that's true. In Midtown, you'll see all these huge buildings, and there's a reason for that. So that, I love that example, Fran. That was awesome. All right, so we're gonna come back to the idea of these minerals, but first we're gonna do a little hands-on activity to build us up to this content that we've just introduced.